Hello, everyone. In the last session, we saw that object-oriented programming basically means computer programs that are based on simulations of real-world objects. In today's session, let us learn about objects that make up object-oriented programming. Objects, both in the real world and in the world of programming, are entities that have certain basic characteristics. The most important of these characteristics are identity, type, state, and behavior. Every object in an object-oriented program has an identity. In other words, every occurrence of a particular type of object, called an instance, can be distinguished from every other occurrence of the same type of object, as well as from objects of other types, which basically means every object can be uniquely identified and differentiated from others. In real world, this difference is easy to identify. Let us consider few real-world objects and understand. Pick up two apples, and you know that although both of them are apples, you know that they aren't the same apple. Each has a distinct identity. Both are roughly the same color, but not exactly. Either one, or both, could have a worm inside. Open a file cabinet that's full of invoices, and you find page after page of papers that look almost identical, but each one has an invoice number printed somewhere near the top of the page, just as your name gives other people an easy way to identify you. In object-oriented programming, each object has its own location in the computer's memory. Thus, two objects, even though they may be of the same type, have their own distinct memory locations. The address for an object provides a way of distinguishing one object from another, because no two objects can occupy the same location in memory. Object identity in Java. Unlike in C and C++ programming language, Java keeps each object's identity pretty much to itself. In other words, there's no easy way to get the memory address of an object. Java figures that it's none of your business, and rightfully so, as it can cause all sort of problems. When used with objects, the equality operator actually tests the object identity of two variables or expressions. If they refer to the same object instance, the two variables or expressions are considered equal. Java objects have something called a hash code, which is an int value that's automatically generated for every object and almost represents the object's identity. Two objects that are equal will always have the same hash code, but two objects that are not equal are not guaranteed to have different hash codes. Next characteristics of object is type. Objects have type. Consider human face. It has eyes, nose, ears, which are common to all humans. So the object's eyes, nose, and ears belong to a type face elements. Similarly, in Java, objects are defined by class. Let us create an example statement that creates an object of type invoice. Type invoice, which we are assigning to variable I, is a new object of class invoice. Next characteristic is state. Objects have state. Consider the following. 1 fish. 2 fish. Red fish, blue fish. In the above, we have a pair of objects of type fish. The fish type apparently has 2 attributes. Can you guess them? They are number and color. The type of an object determines what attributes the object has. Thus, all objects of a particular type have same attributes, and they do not have same values. The combination of values for all attributes of an object is called the object state. Object state can change. For example, the red fish can change its color to blue. The total sales of a customer changes each time the customer buys another product. A student's GPA keeps changing each time a new class is graded. Here are a few interesting details about object state. Some attributes of an object are publicly known while others can be private. The private attributes might be important for the internal working, but no one on the outside knows that they exist. In Java, state of an object is represented by instance variables, which are called fields. A public field is a field that's declared with public keyword so that the variable can be visible outside the object. Objects have behavior. Another characteristic of objects is that they have behavior, which means that they can do things. Like state, the specific behavior of an object depends on its type. But unlike state, behavior isn't different for each instance of a type. Let us understand this with the help of an example. Suppose that all the students in a classroom have calculators of the same type. Ask them all to pull out the calculators and add 2 numbers, any 2 numbers of their choosing. All the calculators display a different number, but they all add in the same way. That is, they all have a different state but the same behavior. Another way to say that objects have behavior is to say that they provide services that can be used by other objects. Someone who uses the object needs to know what the object does, but doesn't need to know how it works. Thank you for watching the video. Meet you in the next session.